Welcome back from an ad break. So now we're going to do some application questions. So these questions are similar to what we experience in our daily lives. Let's see if there's any correlation between what we're learning here and our everyday lives. So let's begin. So we have a table here that says, use the images of the different states to help you fill in the table. So we have solid, liquid, and gas. So we have a solid, a liquid, and a gas. And we have particles that are arranged in a certain way, in a certain pattern for all different states. So the question is, what is then the arrangement of particles in a solid, also in a liquid, and in a gas? So we know that in a solid, the particles are arranged, they are tightly packed. The particles in a solid, they are tightly packed. And then in a liquid, they are loosely packed. Whereas in a gas, they do not have any specific pattern, so it's a random shape. So it's a random. Second one is the movement. How do the particles in a solid move as compared to a liquid and also in a gas? So in a solid, we know that the particles, they vibrate about a fixed position, whereas in a liquid, the particles, they slide over each other. So the particles in a liquid, they slide over each other. And then in a gaseous phase, the particles, they move randomly. So the particles in a gaseous phase, they move randomly again. Now, thirdly, the spaces between the particles, the spaces between a solid, between a liquid, and also between the gases. So the spaces between a solid, they are very small. So we can just say very small. So in a liquid, they are slightly bigger. And then in a gas, they are very big. Then now, what about the strength of force between the particles, the strength of the force that holds the particles together? What about it in terms of the solid, a liquid, and a gas? So in a solid, the force of attraction between the particles, it is very strong. Whereas in a liquid, it is slightly stronger. It's slightly strong. Which means it is slightly strong but weaker than the force of attraction between the solid particles. Whereas in a gaseous phase, the force of attraction between the particles, it is almost non-existent. So we can say it is very weak. It is very weak to a point that it is almost non-existent. That's why now the particles of the gas are able to move around randomly, fill up the entire space, and that is why you can be able to smell that perfume that is being sprayed in a different room. Now, we need to apply what you know again into these questions. The question says, use the particle model of matter to explain why solids have a fixed shape, but gases fill all the shape of the container they are in. Why is it that the solids, they have a fixed shape, but the gases, they fill up the shape, they fill the shape of the container that they are in? If you put them in a circular container, they're going to fill up that space. But if you put in solids within that circular container, they will be stationed within a specific shape or a specific pattern. They will not fill up the space. Why is that? So the reason for that is solids, they consist of particles that are closely packed and they're tightly held by an attractive force. So that attractive force, as remember, we said in a solid, it is very strong. So they're tightly held by that strong attractive force. This close packing and strong force gives solid a fixed shape. So that is why they are unable to take up the space of the container because of the force that is holding them together in a specific shape. Whereas gases, on the other hand, they are loosely packed with very weak attractive forces. And because the attractive forces are very weak, those gas particles are able to move around randomly within that given space and fill up the container. Which is why solids have a fixed shape and volume, and then the gases also, they don't have a fixed shape, and also they don't have a fixed volume. So they don't have a fixed shape, and also do not have a fixed volume. Next question. You've seen someone baking, probably on TV, or your mother baking. So you probably was wondering, why is it that you can be able to pour a flour? And if flour can be poured from one container to the next, does it make flour to be a liquid? Question is, think of a bag of cake flour. You can pour the cake flour out of the bag into a mixing bowl. Does this mean the flour is a liquid? And you need to explain whether you think the cake flour and all other powders are solid or liquid. The cake flour that you can pour from the bag into a mixing bowl, is it a liquid or is it a solid? And I want you to explain, based on the cake flour and all other powders that you know, whether they are solids or liquids. So, the cake flour is not a liquid, that we know. Why? Because if you put your hand inside the cake flour, your hands don't get wet. So therefore, the cake flour is not a liquid, but it is a solid. The cake flour and all other powders, they are solids. So from today, now you know. All other powders, cake flours included, they are all solids. And those solids are made of very fine grains which can flow freely when container is shaken. So when you shake the container that has the flour or any other powder, the particles of that particular powder, they can move freely. So each tiny grain making that cake flour, or each tiny grain making that powder, it is a solid. So flour is not a liquid because the powders do not evaporate, but liquids evaporate. Powders do not wet your fingers, but liquids wet your fingers. So that's why powder and the cake flour, more specifically, it is not a liquid, but it is a solid. Because if you put your hand inside the cake flour or inside any other powder, you can think of a washing powder, for instance. If you put your hand inside there, your hand doesn't get wet. But if you put your hand inside a glass of Oros that you're probably drinking, or a glass of water, your hands are going to get wet, your fingers are going to get wet. So that's the difference, the main difference. The solids, they do not get your fingers wet, but the liquids, they get your fingers wet. And because of the other reasons that you have stated here. Next question. Explain, on the basis of the particle model of matter, how ice, they are being specific now, how ice changes into water, and then water changes to water vapor. So basically looking at the states of matter, the transitioning of the states of matter from the solid, liquid to a gas. Specifically here, we're looking at ice that is going to change from a solid, it melts into a liquid, and then if you increase the energy, or add the energy, it is going to turn into a water vapor. That's now in a gaseous phase. How does that happen? So, when we heat that ice, when we add energy onto the ice, the particles that are making up that ice cube, they are going to move around even more faster, and when they move around even more, they're going to start to overcome the attractive forces. And once they overcome the attractive forces, they move away from each other. And once they move away from each other, then that solid, that ice cube is going to start to turn into a liquid, because the particles are now moving away from each other, filling up and taking up the space of the container. Now, if you continue applying heat, or if you continue adding heat onto that liquid, the water is going to turn into water vapor. Why? Because the particles again will gain that energy that is being supplied into it, and they're going to move around even more vigorously. And once they do, they will overcome those little bit of forces that are still left there. And once they overcome those attractive forces, but then in a liquid, they're going to move around even more further away from each other and fill up the container, and therefore turn into a water vapor, or turn into a gas that we can say it is a water vapor. So now, another question here is, we know that matter can exist as solid, liquid, or gas in all three states of matter. We then need to list the movement of particles to most movement of particles. So looking at these particles, the solid, the liquid, and the gas, we need to arrange them in such a way that they are moving from the least movement to the most movements. Which ones of the three have the least movement? The particles of this matter have the least movement, and which ones have the most movements between them? So we know that the least movements, the solid particles, they are just vibrating. They are not moving. So therefore, their movement is the least. So therefore, this is going to be a solid. From a solid, you're going to go to a liquid. And from a liquid, you're going to go to a gas. So as you're moving from solid, liquid to gas, the movement is increasing of the particles. The next question, again, arranging these states of matter from the weakest force between the particles to the strongest force between the particles. So which ones will have the weakest force between them, and which ones will have the strongest force between them, looking again at these three states of matter. We know that in gases, the particles are far away from each other, and the force of attraction between the two particles, or between the gas particles, is almost non-existent, which then means it is the weakest intermolecular force, or the weakest force of attraction between the two particles of gas, if there are two. So this is going to be gas as the weakest, going to a liquid, and then the last one, the one that is the strongest forces between the particles, is going to be a solid. Remember that the forces within a solid, they are slightly weaker than the forces between a liquid particle. They are slightly weaker than the forces of a solid, but then they are also slightly weaker than the forces, or they're slightly bigger or slightly stronger than the forces of a gas. Then the last question, we also again need to list in this order, from the smallest spaces between the particles to the biggest spaces between the particles. Again, between these three states of matters, which one has the smallest spaces between the particles? List them in that order. So the smallest space between the particles, the one that has the least space between the particles, is your solid, followed by a liquid, and the one that has the biggest spaces between the particles is going to be gas, because the gas particles are far away from each other, and because they are far away from each other, the space between one particle and the other keeps on increasing the more the gas particles move further and further away from the other particle. Now we've answered all of these questions, which brings us to the end of this part. We're going to quickly take an ad break, and I'll see you right after this.